The purpose of this program is to introduce you to several of the key pieces of heavy equipment most often used on mine sites and large earth-moving construction projects. These work sites are busy places and expose workers to a large variety of hazards and dangers. Because you will be on the work site and exposed to one or more pieces of heavy equipment, it will be helpful for you to have knowledge of all of these machine types, see how they are similar, and understand the way in which they interact with one another. Therefore, the goal of this program is to provide you with as much of the basic knowledge needed to help you move safely forward on a career path working with heavy equipment. Getting a major project off the ground requires a lot of planning and legwork. Once the cutting of access trails and the surveying and marking of the initial work have been completed, the real work begins when the machinery arrives on site. Two machine types most often on site first are the crawler dozer and the hydraulic excavator. We will begin with the crawler dozer. We spoke about a typical workday, but what about working at night? On many work sites, operators run equipment around the clock, and as you may well imagine, that presents a whole new set of challenges and safety concerns. For the most part, humans work safer and more efficiently during daylight hours. At night, we fight the natural tendency to rest and sleep, so in order to work safely through the night, we must learn ways to adapt to a whole new set of conditions. By far the best step you can take is to be well rested. When there are many back-to-back night shifts, an operator needs to try and adjust their body clock. For some, this is easier than for others. But if you struggle, don't feel that you are on your own. Material to help you learn ways to adapt is available. Check with your employer, your doctor, or go to the internet, but be sure that what you do is safe and acceptable to your employer. Recognize that not everyone is capable of working through the night. If you are one of those who can, find out what best works for you to stay alert and safe. You owe it to yourself, your family and friends, and to those you work with. Let's shift our attention away from equipment and look at the working environment. Here, combinations of engineered and administrative controls are developed and put in place to promote a safe work site. Let's look at how some of these controls affect equipment operators. An obvious example of structure and order is traffic control. Some operators do not find themselves on a road very often, but for those who do, there needs to be rules of the road. Each work site will have clear guidelines for the movement of traffic. There are questions like: do vehicles follow right-hand or left-hand drive? Who has the right of way at an uncontrolled intersection? Are you allowed to pass other vehicles? Knowing the answers to these questions and others like them determine if an operator is part of the safety solution or part of the safety problem. If you don't know, find out. To understand how a diesel engine works will make it easier to understand why the startup process is so dependent upon an operator doing the right things at the right time. Whereas a gasoline engine requires a spark for ignition, a diesel engine does not. Instead, it depends on heat created by compressing air to ignite the fuel. To achieve fuel ignition, the engine's pistons must compress air to a pressure of 580 pounds per square inch, or almost 4,000 kilopascals. This kind of pressure results in a combustion cylinder temperature of 550 degrees Celsius or 1,022 degrees Fahrenheit, and that is enough to sustain a continuous combustion cycle. When comparing these two engine types, you find that the diesel has an efficiency of 30% or more compared to a typical gasoline engine, which has a fuel efficiency of around 25%. Factor in an additional 10% more energy per volume derived from diesel fuel, and you can clearly see the advantages of using diesel engines to power heavy equipment.